Welcome to St Helena Secondary College, home of nanotechnology, where students and teachers have been working very hard to introduce nanotechnology in science and other subject areas across the school. This video demonstrates some experiments that students can participate in to learn more about properties of materials at the nanoscale. The experiments were developed by Alex, Jason and Jake during work experience at RMIT University under the guidance of Dr. John Facundo and his assistants. Properties at the nanoscale are different from bulk properties. These experiments investigate the colour of gold at the nanoscale. Evidence of the first use of nanoscale properties was found in Roman artefacts like the Lycurgus cup. This cup is made with glass, incorporating gold nanoparticles, which result in a colour change of green to red depending on the angle of light. The colour effects of nanogold are also evident in stained glass windows. Let's now start with the first experiment, making gold nanoparticles, which are clusters of gold atoms. It is a reduction reaction between orochloric acid and sodium citrate. The first stage involves preparing a solution of a gold salt, orochloric acid. Alex accurately weighs out the gold salt, just a few yellow crystals. He adds enough distilled water to make a 0.25 millimolar solution. Note the faint yellow colour. Jason is making the 5% sodium citrate solution used to create the gold nanoparticles. The citrate reduces the gold ions to gold atoms. It also acts as a shielding agent. This means that the gold atoms stay as nanoparticles because they are coated in citrate. Jason is weighing the sodium citrate, which will then be dissolved in 100 ml of water to create a 5% solution. It is important to make this solution up fresh on the day. Note the solution is clear. Jake will now make the nanoparticles. Jake starts by placing a magnetic stirrer into a flask to enable proper mixing of the solution. He adds 200 ml of the gold salt solution and switches on both the magnetic stirrer and the hot plate. After boiling, he removes the watch glass and adds 1 ml of the citrate solution into the centre of the flask. He replaces the watch glass to prevent evaporation. The citrate solution reacts with the gold solution to form gold nanoparticles. Note the colour change. As the chemical reaction takes place, gold atoms aggregate to form gold nanoparticles. The interaction of light with these nanoparticles results in the red part of the spectrum being reflected. The gold nanoparticles now appear to be red. As the chemical reaction takes place, gold atoms aggregate to form gold nanoparticles. It is clear from the scattering of this light beam that there are gold nanoparticles suspended in the solution. The light beam cannot be seen in the solution of orochloric acid, as there are no suspended particles.